this is the part 3 of handwritten digit recognition. I hope you have watched my previous videos, that is demo part 1 and part 2 of this project. Now in this video I will use SVC, support vector classifier, to fit my model, and also I will calculate accuracy, and also in this part I will save my model using joblib. Before writing code, you need to install two packages, that is matplotlib and joblib. So using pip, you can type pip install matplotlib and pip install joblib. Install these packages first. This is the dataset that I have made in part 2. Now I have to separate dependent and independent variable, that is label in one variable and all other in another variable. Let's do it. Let me write title, separation of dependent and independent variable. Yox equals, I have all data in my data list, so let me write data.drop. I will drop label, and x is equals 1, and I have to put label in list. What is this? I have dropped or removed all label, and I have only inserted pixel value in yox variable. And x is equals 1 means separate vertically. If I write x is equals 0, it will separate horizontally, which I don't want, right? I want to put all pixel value in my yox variable and remaining label in y variable. This way we can separate dependent and independent variable. Let me execute this cell. Now let me preview one image using matplotlib. Let me write title. I have to import matplotlib. Also let me import cv2. I have to write one index value, suppose this 314. Now img equals yox. Yox means this yox dot loc. I have to pass index value dot values. Also I have to reshape it into 28 by 28 pixel. I will get one row in my latest line of code, reshape it into 28 by 28 pixel. I am only using yox values. My label is in y variable, right? Let's see, using only x values, it can return my y value or not. Means using pixel value, it will return label or not. I will also print label to check the output. At the last, I have to show my image. So label is 3 and also the image is 3. Both of them are getting matched. If this picture is not showing, you can write matplotlib inline. I haven't mentioned this before, I guess. Now I have to split my model into training and testing part, which is very important part in machine learning. First of all, I have to import train test split from sklearn. If you haven't installed this package yet, you can write pip install scikit-learn. Then let me write train yox, test yox, train y, test y equals train test split. I have to pass my dependent and independent variable, and test size equals 0.2. So what is this? Test size equals 0.2 means 20% of the images are used for testing purpose and remaining 80% of the images are used for training purpose. Training images are used to create my model, whereas testing images are used to calculate accuracy. In my training part, I have to give both pixel value and label to my model. Means I have to teach or train my model. That means I will give pixel value and I will say label of that pixel value. I will teach my model. Another, in testing part, I will only give my pixel value to my model. My model has already learned in training part, right? In testing part, only using pixel value, it has to return my label. And we count how much of my images get correctly predicted, which we call accuracy. I hope you are getting what I want to say. If you have any doubt related to this, ask me in the comment section. And always you have to give more images to training part, that is about 70 to 80%, and remaining images to testing part. This is the ratio or division you have to remember. Let me execute this cell. Now let me write another title. I have to fit my model, and also I have to save my model. I have to import joblib. It is used to save my model, and also I have to import SVC from sklearn. Then let me write classifier equals SVC kernel value. Let me pass linear, and let me pass random star equals 6. What is this? If you search SVC documentation, you can click on this first link and you can read about all the parameters that I have passed. It is very good practice to read documentation of any models or packages. I will leave it to you. Then let me write classifier.fit. I have to pass train x and train y. As I have already mentioned, training data are used to create our model. And to save my model, I have to write joblib.dump. What I have to save? I want to save classifier, so I have to pass classifier. And then I have to give a path and name of my model. I didn't have model folder in my directory, so let me create it first. Great. Now let me execute this cell. Great. We have successfully created our model. Inside this model folder, I have one DG recognizer file. Next time, I don't need to create my model again. I can simply load my model and use it. Finally, let me calculate accuracy. I have to import matrix from sklearn. Then let me write prediction equals classifier.predict. I have to pass test x. I have already mentioned testing data are used to calculate accuracy. And while calculating accuracy, we don't need to provide label, so I am not passing test y. Now let me print one message. I have to write matrix.accuracy score. I have to pass prediction, and also I have to pass test y, because my model will return the label and I have to check that label to know whether it is correctly predicted or not. This is how we can calculate accuracy, right? Let me execute this cell. Oh, it's not classifier, it should be classifier. Okay, great. Accuracy is 97%. This is very huge accuracy. That means out of 100 images, it predicts 97 images correctly. Oh, that's awesome, isn't it, guys? So we have completed part 3. In the next video, we will live predict our images. See you there. Like this video, please friend. Subscribe my channel IG Tech Team. I will meet you soon. Stay safe and keep learning.